Hello and welcome everyone. In this chapter, we are going to see the demo for STP. So first of all, we'll have to take the switches here. So far, I'll take this switches. Let's say switch 1, switch 2 and switch 3 I have. And after that, I will have to connect my switches together. So I will connect my switches like this. The connectivity is also done. Now make sure once the connectivity is done, it is important that you must set up the trunk between the switches. That's very important. Okay, so what to do first? First of all, we'll go ahead and change the switch port mode trunk for all the switches. Okay, so let's do one thing quickly. In all the switches, we will define the switch port mode trunk, switch port mode trunk. Okay, say this. This is my switch 1. I'll say enable configure terminal and interface range fs0 by 1 to 2. You can see that 1 to 2 is the range. Basically see that 1 to 2 is the range, and for this I will define switch port mode trunk, switch port mode trunk. That's it. Close this. After this I will go ahead and do this for this as well. See here, enable configure terminal interface range fs0 by 1 to 2 switch port mode trunk. That's it. After that, go to the switch 3 also and define the same switch port interface range fs0 by 1 to 2 switch port mode trunk is the command. That's it. Once it is done, you need to go ahead and do one thing: verify show a spanning tree. See that once you do show a spanning tree, can you see that there is something like root and root information is showing here? Correct? See that root bridge and election process and everything has been done. Correct? See that? If you go ahead and verify here also, see that show a spanning tree, all designated port, and this is basically your root. Correct? No? So what exactly what I'm trying to say here is, the moment you connect your multiple links between the switches, I mean the redundant link between the switches, and configure the trunk, STP will become active automatically, and it will do its job by itself. Okay, so what you need to do, you need to understand its algorithm. You need to understand how STP algorithm works, that how it selects the root bridge, root port, block port and everything. So let's do one thing. We'll go ahead and check it out the MAC address of your switches, and we will do the manual election here, and then we will cross check whether it is correct or not. Okay, so far let's do one thing. To verify the MAC address of switches, you need to define one command: show version. Show version is basically the commands, and base Ethernet MAC is basically the MAC address of your switch. MAC address of your switch. Anyhow, switch port has the MAC address, but the point is you need to have the base Ethernet MAC, because that will be considered as your switch MAC address. So this is my MAC address. I'll go to this switch and say that show version. In this base Ethernet MAC, I'll take this MAC address, and this MAC address is the switch MAC address. Just copy and paste here. Done. Similarly, go to this show version is the command, and say this base Ethernet MAC. Just copy and paste here. Say this. Done. Now see, in this case, which switch is going to be root switch, root port and block port, you need to identify by yourself. It's very easy process. Say this. First of all, which elections will take place? First of all, yes, first of all, your root bridge election will take place in all the switches, right? And to go for it will be using up your lowest priority plus lowest MAC address. Since priority is same in all the switches, the lowest MAC address will be the next option for you. So go for that. MAC addresses 000, 000, and 0 0 is here, correct? So this is already out because 0 0 D is the not the matching one. This is already out between this 0 0 0, then 6 and 0 0 1 is the lowest one. So this is going to be your root, and after that this is my non-root, this is non-root. Your root port election will take place now in this. So what happens? Cost is 19, 19, 19. So you can go directly just 19. You go via this 19 plus 19, correct? So the best one is this. This is my root. This is my root port, and in this again 19 and 19 plus 19. So this is going to be a root port, and this is my designated port. Designated port, block port will be in this. Stand in the middle and add the cost. 19 plus 19, 19 plus 19, both are same. If it is same, then it will look for lowest MAC address, correct? You go via this, see the MAC address 0 0 0 0 0. D is the more, so this is not at all a good one. This is going to be designated and this is going to be block, correct? No, is it clear? You see this, this is root switch, this is my root port, this is my block port, and this is my root port. You can verify. Switch 2 is the root switch, and in switch 3 this port number FA0/2 is the block port. This is what you need to verify. See this, click on this and verify. Show a spanning tree is the verification command for this, and you can see that is this. See this, this bridge is root, this bridge is root, means this is my root switch. And also you need to see bridge priority is 32768 plus VLAN number 1 extended. That's what here, this is extended bridge ID, okay, because it is for VLAN 1. 32769 it is showing, and all the ports are in designated port. Go to this switch 3 and verify. Show a spanning tree, and you see here definitely there is a block port available, and that's what here, the block port FA0/2, which is connected to switch 1, correct? And this is basically your root information, this is your own information. Can you see there is something called as 2, 20 and 15? What exactly this? These are basically STP timers. These are STP timers. So we'll see that what exactly STP timers and how STP timers are going to work. So just a quick update on the same. Say for example, what if root port is going down? This root port is going down. Then what happens? See, interface FA0/1 shut down manually. If it is down, show a spanning tree. Can you see that? Your different port is going for listening state. This is listening state. It will be there for 15 seconds in this particular listening state itself. The port which was blocked here, that is going for listening state. Now see that it has been changed the state to learning state, and it will be there for again 15 seconds. Still no communication here, it is in learning state. And after 15 seconds, now it become into the forwarding state, and now the communications will take place. So make sure, this is very very important points that we need to remember, that if the root port is going down, the block port will become the root port after 30 seconds of time, and that is basically called as forwarding delay. That is called as forwarding delay. Now say for example, if your root switch itself is going down, let's say switch 2 is going down. So switch 2, if it is going down, switch 1 and switch 3 will wait up to 20 seconds to advertise themselves as a root switch, which is called as max ace timer. And hello timer is the BPDU timer which is showing here. Okay. So I will go for this again one more time in the next lecture, and I will show you this all. So that's it for this particular. I will do one more thing. I'll go to this and simply say that no shutdown. If no shutdown, if you define, again the topology will be run and it is going to calculate the same. See this, the election process has take place, block, listening, learning, the process is happening. So basically this listening learning is taking time, and this is basically called as forwarding delay in STP. Okay. So that's it for this particular lecture. I will see you in the next lecture with the different.